welcome you all to the PACK-NIN webinar series. This PACK-NIN project focusing on lignin-based composites for food packaging applications. I introduce myself. I am Sudha Isekimuthu. I am a Marie Curie Fellow at InnoRenew Center of Excellence. Today our presenter is Dr. Igor Karlovits. I introduce about him. He is head of the department for print and packaging at the Pulp and Paper Institute, Ljubljana. He worked as a professor and a head of production at DS Smith Slovenia, and has experience from both academics and the professional world. And he is currently engaged in development and research of bio-based packaging from agro and industrial side streams. So basically, he is valorizing the agro and industrial side stream waste to the packaging application, into the packaging application. He is now the author of second circular packaging conference, and it's going to be this conference going to be happening in Slovenia. And also is MC representative of Slovenia in a large cost action naming CIRCUL-A-BILITY cost action. It's there are a lot many MC members from different countries, and they are discussing about a solution for bio-based packaging and developing the applications for based on bio-based streams. So now I welcome Igor to present his work. And one more thing, if you have any questions in between, you can post your questions in the chat. Then at the end of the presentation, it's going to be discussed. Thank you. So now you can start, Igor.
Okay. Thank you, Sudha, for a nice introduction. You will see the questions in the chat because I will focus on the presentation. As you said, on the end we will answer any questions. Hello, everybody behind the black screens in the vast world of digital media. As Sudha presented, I'm working at the Pulp and Paper Institute, but I also will be today a little bit iconoclastic. Because I don't see, I will try to show in my presentation that bio-based or wood-based materials are the only solutions for the problems regarding greenhouse gases and the sustainability of our world, but they are a very important part. So my presentation for today, as you already know, is can bio-based packaging save the world from waste, or do we know something more? And I always like to start my presentation with a very wise quote from Umberto Colombo, Italian scientist, who said that the challenge of our millennium is in the balance between the technical means that we possess as humans and the wisdom how we will make use of them. If we see this picture, they are both about carbon, because carbon makes life and also makes death of the earth. And we will have to be very wise in choosing the appropriate materials, not for just packaging, but for all materials surrounding us, like construction or automotive industry, that we don't turn our trees into factories like these ones. Like we see the coal mining chambers in the background. Let's be very honest in this presentation. As I said, I come from a pulp and paper background, but I'm not in the trench of the pulp and paper industry. And I will explain why through my presentation, because there is a battle of profits in the name of environment. Let's be honest, the plastics industry or the petrochemical industry, which is using enormous tons of billion cubic meter gas yearly, slept for decades in developing viable recycling technologies. They just didn't thought about it. There is currently a trend because of the outside pressure in promoting so-called chemical recycling as a quick patch. But it hampers the profits of all companies because it's cheaper to produce new plastic substances than to recycle them. And the pulp and paper industry, excepting the packaging sector, has a decline in classic printing and writing paper, which is connected with consuming the media. We are all looking at our telephones and are not so much in the daily newspapers and magazines. And they also wanted to increase their selling by adding high added value products. And as I said, paper and plastic all have good sides, all have bad sides, and we have to use them, as I started with the quote, very wisely, because in this we have to be together, not in trenches, but in common fight against pollution. Why I'm saying this, I was at one conference here in Slovenia when the president of CEPI has a talk to paper makers, and it was like this: the plastic people are on the ground, they're under pressure, this is our moment to overtake the market. And with a speech like that, I was very appalled, because I don't think that we have to do all this for the profits, but we have to do it together in the name of environment, sustainability, and our future as a species on this planet. So everything we do regarding packaging, and not just packaging, but we have to include packaging as a topic of this presentation, is about crunching or reshaping the carbon flow. Of course, packaging is not the main consumer of carbon and the releaser of carbon dioxide, but it's a very important one, because we also have the power sector, the residential, tertiary sectors, we have the industry, the transport. And when we talk about crunching or reshaping the carbon flow, everybody's talking about improving efficiency. Then we will substitute the fossil fuel before we got out this very big carbon budget bubble, and things get very warm. And the end idea is that we replace the oil-based materials, and that will be the end of waste. But is it really the end of waste? With the mindset we are currently shaping throughout all sectors of the industry. So where does packaging come into this? As I said, packaging is not a dominant user of petrochemicals, but it's a very important one. If you see on the right side of the presentation, it's around 40% of the petrochemicals is going to packaging. The other ones are going to building, textiles, and other things like that. So it's a very important part. And for example, if we take the information that the petrochemical industry is producing 400 million of metric tons of plastic every year, which is around the weight of 1,000 Empire State Buildings, then it's a when we translate it to the packaging sector, it's a huge problem at the moment. And as we can see on the left side, Europe is currently stagnating with the plastic production and plastic consumption, but the world is rising. Mainly US, China, India, and few developing countries or countries with very big economies are producing more and more plastic. And of course, that's why the whole topic about using bio-based materials to reshape this carbon flow, which I mentioned on the previous slide. But why is not this happening, or why it didn't start it before we got into the trouble with the greenhouse gases and the global warming? It's very indicating where are the pressures on the industry. When I'm talking with different stakeholders in the, for example, the food production industry, what is important for them, and I also found this very good survey from Huhtamäki, they all say product safety, food safety number one. They're just caring about food safety, food contact safety, and all the pressures from the policymaker is on the food safety side. And for example, the consumers are more and more interested in the last few years in waste and recycling and climate emissions. And basically the industry is changing their perspective, but not because they want, but they are adjusting to the market trends. But the policymakers who are reshaping the landscape, what is the priority, as I said, in few years, regarding regulations were much harder on the producers, on the product safety side, food safety, than on the recyclability, compostability, and other things which are concerning packaging materials. And this is a real situation on the market. And if I say, okay, why don't you use a more sustainable recycled material? Yes, because we will lose all the things which are required by the law, which ensures the food safety of the material. So it's basically a game of policy making and game of different interests from different stakeholders. And as I said, it is the regulators who have to push the producers in the whole value chain, the converters, the fillers, the sellers, the end-of-life managers, the suppliers, regarding sustainability and regarding recyclability, because they have the power to shape what kind of regulations or what kind of packaging material is needed that we crunch this carbon bubble. The European Union started a way with policy making to further down the waste, as I said, as the end of this carbon crunching way to the net zero society. And for example, they increased the targets for recycling rates and climate neutral continent to 250. That sounds very promising, but can it be done with bio-based materials? What I'm missing in all this policy making for the European Union is the clear message of the overconsumption. So their tactics currently or policy making is, okay, so let's recycle more and use more bio-based materials and things will get better. But if we look, for example, in 2020, the top environmental scientists declared overconsumption as the main threat for sustainability. So basically, the European Union doesn't want to push the real button, and the first button on the waste hierarchy is prevention. Then we have the preparing for reuse, recycling and recovery, and basically they don't want to touch that first button. I will say my personal opinion why is that, but they are using bio-based materials as a kind of getaway to solve the problem. As I said, why is this point missing? Because these changes are very complex, because they will have to change the whole system, states, economic models, business models of countries, of citizenships, of companies. And of course, there is no easy and clear ways and solutions. And the policymakers or the politicians, let's be honest, they are looking for short-term gains without very agitating their voting population. And also companies with their greenwashing many times play the feel-good green theater and use these greenwashing tactics without changing their business model. Because let's be very clear, is there a company who is brave enough to say, please buy less of our products, because it's the kind of reducing consumption. And my question when I'm talking with stakeholders from the industry and research, and I also have some personal doubts, are as we scientists who are working in the sustainability packaging business, helping this process with our inventions, or we are just helping the industry to make a green scaffold over our eyes that we think, okay, we develop something bio-based and everything will be all right. These are very serious questions, because as I said, these are systemic changes. And for example, if we look into very prominent works regarding changes, there are some models how to go to more circular. And for example, my opinion is that too much focus is currently on the product level, and the R&D departments, including Lignin, including nanocellulose and other stuff, are very much going around in this box and trying to solve the problems with just bio-based materials. But to really circularly society that we don't burst the bubble, which is going with the carbon emissions, we have to go from this product level to product service system level. There are some things, for example, reusable, refillable packaging is some kind of behavioral changing systems together with the product level system, that you have a shape, the right material that can be refilled, reused as a packaging material. And then there is the spatial social level and social technical system level, where the end is not eco design. Everybody's talking about eco design, but it's a very old story. It's about design for system innovation and transition that will change our whole concept of living and working. But as you can see on this screen, it's very systemic, and you have to change people, which are sometimes very harder to change than some material chemical construction. So I found a very good picture from the First World War for this title, as I said, using bio-based material as a cover, because many companies, because of the peer pressure from the users, they have to produce something green, something eco-friendly, something that is good for the nature, and they use this bio-based naming as a cover. But to be knowledgeable, it's to know some things, as not all biodegradable products are made from renewable resources, and vice versa, not all bio-based products are biodegradable. So people have to be very, very good informed, and unfortunately, this is not happening. So what bio-based options are currently offered? For example, bio-based polymers are on the rise. Either they are polysaccharides or proteins. They are either, again, from plant origin or animal origin. And for example, polysaccharides from plant origin, like starch cellulose, they have a lot of market penetration regarding different kind of films, nanocellulose films. I'm talking about the packaging sector. Lignin is also on the rise. And of course, natural rubber is not so common. A lot of papers and a lot of research is done on the chitin, alginates, and animal origin polysaccharides. But let's be honest, it's about quantities if we take the current business model. So I'm not very convinced that there are viable sources for the future. And also, for example, we have the proteins which can stem, for example, from food waste or other biosources. If we take the look of the bioplastic production, we see that it's in last year it was around 2.11 million tons. And if we know the numbers, how much plastic is consumed, so basically it's 1% of plastics in the world currently which are produced from bio-based plastics, but they also have some booby traps regarding recycling, reusing, and how we try to market penetrate with them. One of the scapegoats currently for the bioplastics industry is that it's biodegradable and compostable. If we see the systems where biodegradation or composting can happen, we have industrial composting sites, home composting sites, we have freshwater, we have seawater plus landfill. And all of these different scenarios where we are doing the composting and biodegradation is due to different temperature, different pH values, different different kind of bacteria that is present. It's very, very different. So if you say that, okay, my product is industrial compostable, but there is no industrial composting site anywhere near your living, then you have problems with composting. So these kind of products are not very good as an end-of-life situations. And there is currently very murky waters of biodegradations, because these alternative materials which are offered, or lignin coated, or nanocellulose coated, or PLH, or PHB coated, there is little real information about their real biodegradation in natural, in their natural for example, waters, and these standards has to be aligned with very specific tests, because these needs to be very robust, because not all bioplastics or other materials are going to industrial composting. And for example, there is also poor and unclear, confusing legislations which are coming from unqualified legislation stakeholders, or as many times happen, there are hidden economic interests from various companies that they are making holes in the law through legislation lobbying. And of course, there is corporations through deliberate greenwashing and using double talk that make this green facade without structural changes in their business model. And of course, here with the public or the end users, that we don't have education, or it's too complex sometimes, and the volume of the information is provided is not enough to know what is really biodegradable, what is compostable, and what is happening really in the nature. For example, this year I found a study, there are the first results almost in the world from Wageningen University, that tiny microplastic particles that are coming from bioplastics, which are plant-based, can influence biodiversity. And there was a 50% decline in total number of organisms exposed to micro and macroplastics when they compared it to the control system. So fostering solutions which are biodegradable and compostable without very, very specific and exact ecotoxic and biodiversity studies is maybe a timed eco bomb for the future, that we say, okay, it is industrial compostable, it is biodegradable, okay, we will put it on the shelf. But if nobody tests it in different type of waters with different types of salinity, pH values, temperature conditions, it can be a future eco bomb, because as I said, first results indicate that all of this degraded microplastics and macroplastic is also damaging the biodiversity. And for example, who will pay for this was the first question, because these things are very complex, and for example, you need 1 year minimum to make these studies. And of course, not every company can make for their materials this kind of studies at the current moment, but with some simulation or computer modeling, maybe we can improve this situation on the on the current market. So, as I said, composting is a last choice. It's not something to be proud of, because I see a lot of products that they are say it's compostable. Also, for example, coated paper products like paper cups, paper packaging, and they say, yes, it's compostable. Okay, but you're composting something because of a few percent of the coating, and you're destroying 90% of fiber instead of recycling it. And I don't agree that compostable is, as I said, a very good things to be proud of, because recyclable, it's much better. So if we take the things, and for example, if you check with the end-of-life managers, they are also have already so much food waste in their fertilization or biodegradation units that they are not very happy that they get more and more of materials to compost from packaging, because they also have limited resources. So as I said, it's much better to develop that kind of bio-based materials which can be recycled, not just composted. It's not a good end-of-life options. I'm more to use, for example, polyethylene or polypropylene, which can go back, for example, for good mechanical recycling, than to have some bio-based solution which is compostable. And for example, you are destroying some paper cup with 90% of fiber because you cannot separate the coating from the paper fibers. One thing is also very interesting, that the refill reuse, which is also one step higher in the hierarchy of waste prevention. And for example, in UK, there is a large movement, and a lot of retailers are going to refill reuse. I don't see the trend so much here in Slovenia and also in neighboring countries. And I'm sometimes puzzled. I'm very supportive of the refill reuse system, because, for example, if you look the LCA analysis, the plastic containers or plastic cups have better LCA just after 2 to 4 uses. The plastic bags, if you have a reusable tote for shopping, it's after 11 use, it's much more environmentally sustainable than the plastic bag or the paper bag. So if you take the number of reuses above, I don't know, 3, 4, 10, 15, 20 to some products, you are gaining much more to sustainability than using bio-based materials. Also with, for example, with polyethylene or polypropylene stuffs, for example, glasses, dishes, or things like that. And that's why it's not good to be in trenches, as I said, that, okay, we are the paper side, we will overtake the market from the plastic side, the plastics are bad, they have to change, because the situation is not so easy, not so clear, and I think we will have a common goal to have a better, cleaner planet. The main problem with the refill reuse is, of course, the people. It's about the hearts and not the materials. And we can make the cups from bio-based materials. We can make it from polyethylene. But if we will reuse it 100 times, it's and you have a good recycling schema for the polyethylene, then it's not important if it's bio-based or not, because the larger carbon consumption at the production stage of the products will be diminished through the reuse of this product. So we have to use both materials, and we have to use them wisely. And as I said, is this enough to save the world? So the substitution we want to talk about, including lignin, including nanocellulose, it's not about replacing plastic, but to use them wisely where there is a good possibility. There is, for example, overpacking, where there is some overconsumption of the materials of the packaging, and leave plastic for very special things, like, for example, medicine packaging or some other specific areas. And for example, in the last few years, the pulp and fiber industry started to promote the concept of biorefineries, where they offer, beside fibers, also some kind of other value streams. And there is currently a lot of research, but my opinion, it's not very focused. Lots of LCA studies and CO2 studies are about proving which trench has better results. It's not about that. As we see, there is a plethora of bio-based products from biomass feedstock. For example, from starch, hemicellulose, cellulose, lignin, oil, protein, you can make a million of things, okay? But I think we need data scientists, people, to make feasibility studies and to be very focused what is important to change with regarding petrochemicals. For example, lignin, because this webinar is also touching lignin, currently is tested as a filler and a component in biopolymer films. It has proven enhanced strength, thermal stability, and additional functions. And they are also testing a lot of biocompatibility with PLA, PHA, PVA, and also with animal origin feedstock, where they got some antimicrobial properties, and also with plant-based, for example, with starch-based films. And I also found some applications in foams. But as I said, is it the best option to use lignin, for example, for biofoam? Not necessarily. It's nice for some scientific paper, but not necessarily. Here is an example of pulp mill which is converted into biorefinery and which is producing paper and plastics at the same time. For example, this is a very good concept. The Stora Enso Langebrugge factory will start this year to produce paper fibers and bioplastics. For example, this didn't come just from their goodwill to be more sustainable, but also that they had a decline in newspaper printing production. So they had to find a different output from the paper mill. But okay, it's a good standing solution. Some products which made it to the market from these biorefinery concepts, for example, the monomaterial paper or the nanocellulose films, they have been introduced mostly from the Nordic countries. But if we look, for example, the barrier properties of these kind of solutions, they are still very, very, very far from petrochemical plastics. And again, is this the market that, for example, the bio-based solutions need to go to change, and not, for example, to improve the efficiency of recycling? Why try to catch something which is by nature much better regarding barrier properties, improve the recycling options, and maybe to use your product somewhere where it is more natural to use it and more wise. That is the topic I want to give through the people. Yes, I admit fiber solutions are quicker way to reduce the CO2. And if we do all the LCA analysis in 250, if we go all to fiber-based solutions, we will have much lower greenhouse gas emissions. That is undoubtedly, I cannot argue with that. And for example, there are some kind of different situations where we can change. But I, for example, have a allergy on the paper bottles. Why? In the last 1 year, everybody's doing paper bottles, the so-called paper bottles. But let's be honest, we see on the cap, or if we cross-cut it, there are also some plastics in it, because the fiber-based materials doesn't have good barrier properties regarding liquid. And all companies are trying to produce the paper bottles, and they're all attacking the polyethylene market or the polypropylene market. And what they forget, that polypropylene and polyethylene has a very good recycling systems with mechanical recycling, with very low environmental impact. We can recycle it back, the materials. And here you are using a multi-material paper, fiber, and plastic to do something. And if you look for example, the LCA studies, yes, the paper bottles are better, but the bad guy are the glass bottles. So they are attacking the wrong, they're aiming at the wrong goal. So let's help polyethylene and polypropylene to have better recyclability, and let's change, for example, the glass bottles to paper bottles. Yes, because paper bottles have better LCA studies than the glass bottles. But the problem is that nobody will want to drink wine, for example, from paper bottle, because they are used. It's again about the heart and not about the material that we have to change. So this, for example, this is a very clear way why I'm sometimes not very aligned with the people that want to solve everything with bio-based materials or with fiber-based materials. Okay, the main problem is that if we want to change everything with bio-based materials and biomass materials, where we will source all these bio-based materials. And for example, Europe is currently felling 72% of yearly net forest growth. And for example, if we want to do a substitution of 25% of plastics with fiber-based materials, that would mean that we would need increase this felling by 70% and of the unclaimed net growth. And basically, we would have to use all the available biomass, which is, I'm talking of course for Europe, these are the data for material economics, they got out last week. Basically, we would have to use almost all new net growth of the forest to change 25% of plastics, for example, in packaging or anywhere else. And this would help to reduce 13% of greenhouse gases, which can be also achieved with mechanical recycling of polyethylene and polypropylene. So that's why we have to have a debate with different kind of sectors, because this biomass is not used just for material science, but it also used, for example, for energy. Yes, there are solutions that we make plantations, but do we want forests like these ones? These are planted forests. If you look at the pictures, they are scary to me. Yes, they are trees. Yes, they are producing with photosynthesis oxygen. But if you look the biodiversity and everything what the real forest is bringing to the ecosystem, I don't know if these kind of forests are the right solution for things we are looking for in bio-based packaging. In the finishing of my presentation, I will just try to build up the whole story I'm here telling you. Let's enter the CO2 values. For example, the European Union is set to double its emissions from 43 to 85 million tons of carbon dioxide per year. And while packaging is currently just 1% of EU emissions, this 85% with different structural changes will go to 30% of the remaining emissions. So packaging is very important things to tackle. And if we would like to make Europe completely plastic or CO2 free, that would require energy, because you have to convert all the bio-based materials, around 560 terawatt hours, or 80% of all electricity produced by renewable energy sources in the European Union today. So just that we want everything that is bio-based, and that we want to change it, there is currently very much it's the way is not very clear. What are the options for reducing CO2 emission from plastic packaging? For example, we can reduce overpacking, we can do additional mechanical recycling, we can do substitution today, we can do a future substitution with fiber-based materials. And if we see that it only currently cuts down some kind of a maximum 40 to 50% of the EU target, and the rest is, as I said, in our behavioral patterns, that we will have to lower our overconsumption. So how to redistribute wisely the biomass for packaging? As I said, biomass is scarce and valuable, and if we don't use it wisely, and we want to have it everywhere, there is not enough of biomass for all the applications now envisioned in the laboratories and in the scientific papers. Sorry, the trees are not growing so fast. The continuing trends, current trends, that there is, for example, a 150 increase in bioenergy since 2000. And when we hit the limitations, the plants want to use the energy sector 40 to 100% more biomass than it's currently available just for the energy sector. So the decision makers, the policy makers, and also the scientists have to make priorities, how they use this biomass with the highest economical and social values. And also what they forget, as I try now to input that, for example, bioenergy is also a big user of biomass. Currently, it's around 40 to 60%. 60% goes to energy, 40% goes to materials. And for example, Europe is currently using around 10.3 exajoules of materials. And if we want, for example, in 2050 to change it all to biomass, there will be a 40 to 70% gap of biomass to have also bioenergy and also to have biomaterials and biochemicals. So it's not possible. For example, in Slovenia, the people are still investing a lot of money in burning wood. So that means that everybody had to be shut down from burning wood, and that all the material go, for example, for bio-based things, for packaging or for some bio-based chemicals. So it's impossible with the current rate of biomass. So let's close it this webinar. For example, also the EU wants to cut down intensive agriculture. Also, they want to change different things, and this all will have influences on the arable land and on the available biomass. And for example, we have to be very careful when you cut down trees, you're basically cutting the carbon sinking function of a tree or biomass. So it's not that simple, and you have to make a very good judgment how to use it. And just one more slide and I will finish. For example, where are the reserves for the biomass to have all these ideas about lignin, nanocellulose and things like that? In the forest, not very much. If we see the exajoules that are currently available from the biomass, the residue removals are also not giving much space here. For example, the agricultural crops, the energy crops have something 10 to 15% of reserve that we can use it, or agricultural residues maybe have almost double percent. But for example, paper waste, food waste, and other sources of biomass which we can use, for example, to use lignin, nanocellulose, and other sources, currently is not just there. It's very limited, and we cannot forget this when we are developing some solutions. My final conclusions is that the most important step is to reduce overconsumption of resources and commercial goods, to eradicate the planned obsolescence and force maximum reusing of products, that we think in long-term carbon sinking for all products and this function of the biomass. For classic polymers, that we improve the mechanical recycling or chemical recycling rates, and for bio-based materials that we have a aligned, very strategic talk with policymakers where to put our efforts and money and time, of course, and our knowledge and wisdom, that we have an aligned strategy together with the bioenergy sector. And I will show you at the end the real circular economy diagram, which says that we are not in the center of the circle, but we are part of the circle. And this is not the Ellen MacArthur Foundation circle diagram, but the real circular economy diagram. Okay, thank you very much.
Thank you, Dr. Igor. It's really very nice presentation, and you showed us another perspective of bio-based and packaging field. So it's really nice to have this presentation. So we have received a few questions from the participants. Okay, I will go one by one. From Veerapandian, the question is, what about the production cost when you produce the plastics or packaging material from plastic, petrol-based or bio-based? What is the production cost difference? And
currently, the bio-based plastics, as I know, I think it's around 2 to 3 times more expensive than the non-bio-based. So basically, I had also one company which wanted to change to bio-based plastic, but I think it was a €7 per roll versus €2 for a polyethylene film. So it's 2-3 times more expensive to produce bio-based polymers at the moment, currently, because of the economic of the scale.
Okay. And the next question from Joey. Sorry if I pronounce the name correctly or not. I don't know. Sorry. So his question is, technically glass can be recycled forever if you use the right type of glass for bottle manufacturing. Not the case of paper that is limited resource in terms of recyclability. So I do not see the need to replace glass with the paper in some application from a material point of view. So what is your thoughts on this?
Yes, as I said, this information for the paper bottles, the LCA studies suggest that the paper bottles are 10% of the glass bottles when you see the whole life cycle. So because glass is heavy, you have to remelt it. I agree that you can circulate many times. But this is was a point that the PET bottles can be more easily recycled than, for example, with lower energy than, for example, glass, because you have to remelt glass on a very high temperature. And you can, for example, reuse polyethylene for 6-7 times. So but it's more about as I said, will you drink so much wine? Because if you have, for example, good barrier properties, you can refill the plastic bottle and you can refill the paper bottle more times. You can also refill the glass bottle, but if it breaks, then to make a new bottle, it's much more costly in the CO2 values than, for example, the paper bottle or the plastic bottle.
Okay, good explanation. And next question from Avinash. Professor Igor, nice talk. Could you suggest any technique by which we can remove microplastics from oceans? Is it possible to make materials that could attach microplastics by electrostatic interactions?
I don't know about electrostatic interaction, but at our institute we are using nanocellulose for cleaning, for example, microplastics and dyes from washing machines. And I think with the use of hydrogels or a kind of nanocellulose kind of medusas that we can collect part of the microplastics from the oceans.
Okay. So the next question again from Veerapandian. Will biomass-based plastic affect the food chain in the future if we utilize first-generation plants and considering the increase of world populations?
As I said at the beginning, not all bio-based polymers are biodegradable. So basically, they at the end they have properties like, for example, like polyethylene, and if it's sourced from sugarcane or from corn, they can also make microplastics. And as I said, the studies, the Van Nenigan study says that also bio-based plastics can influence biodiversity. So definitely, my answer is yes, they can influence the food chains in the future.
Okay, thank you. And one final question. What is the short and long-term goal for the bio-based packaging? Like for the moment, we are using only 1% bio-based packaging material out of 40% of total packaging. So what is the short-term goal? What is the how much percentage we are aiming, and what for specifically for what kind of applications?
Okay. If you ask the paper people, they will say 100%.
Okay.
We want to, everything is made from paper. As I said, for example, regarding the biomass for Europe, because I don't have data for the whole world, the maximum that we can aim is, as I said, around 50 to 20%, not to go to 25% of replacing plastic, because we will be very near 100 percent of the using of the net grow of forests, because I forgot to tell that 70% of biomaterials are from wood industry currently, no?
Mm.
And all these agriculture residues are small samples, and we are already using almost 3/4 of the dead biomass, so maybe 15 to 20% of more plastic packaging that can be with fiber things. With bio-based packaging, it will be a good fight with the people who are going against the arable land. Because, for example, Tetra Pak wants to use bio-based polymer in their Tetra Pak solutions, and they said that they will grow these plantations only on devastated land. But why is that land devastated? Maybe because there was a plantation, or because they cut it down trees. What is happening, for example, in Brazil, the people for profit are ruining the rainforest to devastate the land, that they can grow plantation for bio-based materials. So it's more social problem than this. But for example, my opinion is also maybe up to 1/4, and I would like to see it at least 50% of the things are that refillable or reusable, like we used to have, for example, 50 years ago.
Okay, that's a good option for all of us. Okay, then again, Joey. Yes, there are pros and cons regarding the processes, and that will be one of the different factors regarding LCA studies. No materials are perfect. Thank you for your great lecture.
Okay, thank you, Joao. I agree, and that's why I'm not want to be in the trench of the fiber people or the glass people. We have to step together, because, as I said, many LCA studies are ordered by some industry corporations, and of course, when the fiber people order it, fiber is the best solution, replacement material. When the glass people order, it's the glass the best solution. We have to find a way that, that we work together, and yes, there is no easy solution, definitely. That's why I want all us to be wise and use less things that we use today.
Okay, it's really very good and excellent presentation, and everyone enjoyed a lot. And thank you for your time and sharing your knowledge with all of us. Thank you, Igor, Dr. Igor.
Thank
And
you, Sudha, for the invitation.
And thank you all the participants for your presence. And the next webinar will be on 22nd July, and I'm going to send the...
Dr. Sudha?
Yeah, tell me, please.
May I ask a question, if possible?
Yeah, maybe quickly.
Yeah, quickly, yes. Professor Igor, my question is regarding styrofoams. And styrofoams are one of the most problem creating plastic, because they are actually lightweight, but yet they are very difficult to recycle and also to collect also. So nanocellulose forms could replace styrofoams in many applications. So could you tell about the the possibility of nanocellulose forms to replace styrofoams in packaging, in electronic packaging and different applications? I invite your comments on this. Thank you, Sudha.
Okay. Thank you for your questions. For a Slovenian company, we did some studies, and for example, we didn't use nanocellulose foams, but we managed to change the styrofoams, for example, with corrugated board. I'm talking about the protective elements in transport packaging, but we didn't use the classic corrugated board, but the hexa corrugated board, which has a very good properties. And for example, the washing machines can be protected with corrugated board. You don't need the styrofoam protective elements. Regarding nanocellulose, I don't have any data on the biofoams. We mainly did some kind of biocomposite fiber with PLA. So I cannot answer directly from the nanocellulose, but for nanocellulose I have problems if we use a lot of, for example, tempo oxidized or things like that. So that's a very nasty chemicals to make a bio-based material. So it's also, I don't know how green is that technology to use it, for example, instead of, for example, classic corrugated board for some applications.
Yes. Yeah. Thanks, Professor Igor and Dr. Sudha. Thanks for the opportunity.
Thank you. Yeah, it's okay. Okay, thank you all, and see you all again in the next webinar. Thank you, Dr. Igor, and thank you all the participants.
Okay, thank you.
Thank you.
Bye-bye.
Bye.